All right, today we're going to do something pretty cool. We're taking an ancient remedy, something that's been a staple in traditional medicine for literally thousands of years, and we're putting it under a modern microscope. What does science actually have to say about milk thistle's legendary reputation? You've probably heard this before, right? Milk thistle as a liver tonic. This isn't some new health trend. No, this is a reputation that stretches back for centuries, almost like a piece of folklore passed down through generations.
And that's exactly what we're here to do. We're going to move past the historical claims and dive straight into the laboratory to see what the evidence actually reveals about this pretty fascinating plant.
Okay, so to really get to the bottom of this, we need to get specific. We're not talking about the whole plant. We're zooming in on a powerful extract from its seeds called Silymarin. This is where all the action is supposed to be.
But wait, the story gets even more interesting. See, Silymarin itself isn't just one single thing. It's actually a complex cocktail of molecules. They're called flavonolignans. And within this unique family, one member really steals the show.
And that main character is psilocybin. It is the dominant compound in the extract, making up a massive 50 to 70% of the whole mix. More importantly, research shows it's also the most biologically active. So this is our hero molecule, the one right at the center of our story.
It all sounds pretty great so far, doesn't it? We have a powerful, natural molecule with this long history of use. But here's where our story takes a crucial turn. There's a major biological hurdle standing in its way.
And this is the plot twist. Despite all that potential, our bodies have an incredibly hard time actually using psilocybin. Studies consistently show that only about 23 to 47% of it is ever absorbed. In scientific terms, this is a classic case of poor bioavailability. Think of it this way. You got this potent, protective molecule, but it just can't get to where it needs to go. It's like sending a powerful message in a bottle that dissolves before it even reaches the shore. Most of it gets lost in transit, and that presents a huge challenge for its effectiveness in the human body. So why is the absorption so low? Well, it faces this brutal four-part obstacle course. First, psilocybin just doesn't dissolve well in our gut. Then, even if some of it gets into our intestinal cells, tiny molecular pumps, like little bouncers, actively push it right back out. And for the little bit that makes it past all that, the liver breaks it down almost immediately. The result is that barely any of the active compound ever reaches your bloodstream. So, why are scientists so obsessed with solving this puzzle? Because in the lab, where you can just bypass the body's absorption problems, Silybin is an absolute powerhouse. Now, I know this diagram looks complex, but the key takeaway is simple. Silybin is a potent antioxidant, neutralizing these damaging molecules called free radicals to protect our cells. And it's not just about oxidation. Again, you don't need to trace every single pathway here. The big picture is that in lab settings, Silybin can also interrupt key signals that trigger inflammation. Think of it like a switch that can dial down the inflammatory response at a cellular level.
So to recap what we see in the lab, we have this multi-talented molecule. It's an antioxidant, it's anti-inflammatory, it helps stabilize the very structure of our cells, and some data even suggest it could help liver cells regenerate. This is the incredible promise that we see in these preclinical models.
And this brings us right to the core conflict. On one hand, you have this incredible preclinical promise. On the other, you have the reality of human clinical trials. When it comes to liver diseases in people, the results are all over the map. They're conflicting, inconsistent, and ultimately inconclusive. That fundamental problem of bioavailability makes it nearly impossible to confirm if the amazing effects seen in the lab can actually happen in our bodies. And this isn't just one opinion. This statement from the National Center for Complementary and Integrative Health really sums up the current scientific consensus. Despite all the interest and all the research, we just don't have the solid human data to make any definitive claims.
This scientific uncertainty gets even more complicated when we step out of the lab and into the real world. Because beyond the biological hurdles, there are some very practical concerns with the milk thistle products you might find on the shelf.
The NCCIH points out some pretty serious issues here. For one, the quality of supplements can be unreliable, with the amount of Silymarin being significantly different from what the label claims. On top of that, there's a risk of contamination with things like pesticides, microbes, or even toxins from mold.
So we're left with this fascinating puzzle. A molecule with brilliant potential, demonstrated in the lab, but it's trapped by its own biology in the human body. The challenge now for scientists is to figure out if they can finally bridge that gap and unlock the true potential of this ancient remedy.
It's a question that keeps this entire field of research moving forward.